Still on reduction formula. This time we are going to consider integrals of this form: x to the n cos x dx. Alright, so we are going to deduce a reduction formula for this particular integral and apply it to solve problems. So just watch to the end. Okay, so let's deduce a reduction formula for the integral. The integral of x to the n cos x dx. Okay, first of all, let's call this integral I sub n. Alright, let's call it I sub n. Now, using the same integration by part, the integral of u dv is equal to the uv minus the integral of v du. We are going to choose x to the power of n as u, so that if we differentiate u with respect to x, we'll get nx to the n minus 1, right? N times 1 is n minus 1 is n minus 1. And upon cross multiplying, du will be equal to nx to the n minus 1 dx. We have chosen this as u. It means that the other part of it will be dv. dv is simply equal to cos x dx. So to get v, we integrate both sides. The integral of dv is v. And the integral of the cosine function is actually the sine function. You know, if we differentiate sine, we get cos. So integrate cos to get sine. That will be sine x. So I sub n, which is this integral, is equal to u is x to the n, v is sine x, minus the integral of v, which is sine x, du. And what's du? Nx to the n minus 1 dx. Nx to the n minus 1 dx. Alright, this is the same thing as saying x to the n sine x minus this n can come out because it's a constant in this case, since we are integrating with respect to x. Then we have the integral of sine. Okay, before I write the sine, let me write x to the n minus 1 and sine x dx. So this is our I sub n, this. Now, if you look at this right hand side, everything we have here, this integral here contains sine x. The original question, which is the original integral we are integrating, contains cos x. So I want to perform one more integration so that the integral will now contain cosine instead of sine. You get it? It contains sine. I don't need it. I need an integral that contains cosine. To get that is just for me to reintegrate this particular function. Okay, now watch. Okay, let me say I sub n is equal to x to the n sine x minus n into the integral of x n minus 1 sine x dx. Alright, this must be noted. We are not going to forget this. We'll come back to it. Now, I want to choose a new okay, see, for this integral, we have the x to the n minus 1 sine x dx. Using the same technique of integration by parts, we choose x to the n minus 1 as u. So that if we differentiate u with respect to x, that will be n minus 1 in bracket into x to the n minus 2. If you subtract 1 from this, you are going to get minus 2, right? Okay, so upon cross multiplying, it means that du is n minus 1 into x to the n minus 2 dx. dx will multiply this. Good. Now, what will be dv? We chose x to the n minus 1 as u. So sine x dx will be chosen as dv. That's sine x dx. So if we integrate both sides to get v, the integral of dv is v. Then if we integrate the sine function, we're going to get the negative cosine. Differentiate sine to get cosine. Integrate cosine to get sine. Integrate sine to get minus cosine. So this is minus cos x. Good. So for this integral, we have the integral of x to the n minus 1 sine x dx is equal to uv. We are coming from here now. U is this is u. This is v minus the integral of v du. Everything here is du. So we have minus x to the n minus 1 cos x. Minus minus will give us a plus. Then n minus 1 is a constant. It will come out. Times the integral of, let me write x to the n minus 2 first. Then cos x dx. Now we can see that this integral now contains cosine. Is that not so? Yes. So in place of this integral, everything here, this integral you can see here, from here down, I'm going to be writing this whole stuff. So that this I sub n is equal to x to the n sine x minus n, then everything here will be written inside this bracket, minus x to the n minus 1 plus s plus n minus 1 into the integral of s to the n minus 2, okay, cos x dx. All right. Can you see that this integral now contains cosine? So the target has been hit. What next? We said that I sub n is this, s to the n cos s ds. Let me write it here so that we can see. I sub n is the integral of s to the n cos s dx. So it's like we're saying that this function, this integral is a function of n because of this n that we have here. Okay. So this and this, they look alike. Just that in place of n here, we are having n minus 2 here. So if this is I sub n, then this should be I sub n minus 2, which is the integral of x to the n minus 2 cos x dx. So therefore, we now say the reduction formula for the integral of x to the n cos x dx, which is I sub n, is equal to x to the n sine x minus n in bracket minus x to the n minus 1 cos x plus n minus 1. Instead of writing this particular integral, I'll write I sub n minus 2. That's why it's called a reduction formula. So if we expand that bracket, I sub n is x to the n sine x, then n minus n go inside, now have plus n x n minus 1 cos x, and this minus affect this, minus n into n minus 1 into I sub n minus 2. Alright, this is a reduction formula for the integral of x to the n cos x dx. Having derived the reduction formula for this integral, we now go ahead to determine the integral of x to the power of 5 cos x dx using the reduction formula. and hence we will determine the definite integral, the integral of x to the power 5 cos x dx from x equal to 0 to x equal to pi. Correct to 3 decimal places. The power of x here is 5 and that corresponds to n. It means that n is equal to 5. So we are determining I5 and this is equal to, from here, just watch me, x to the 5th sine x plus 5x to the power of 4 cos x minus 5 times 4, right? I3. Because 5 minus 1 is 4, 5 minus 2 is 3. So this is the same thing as saying x to the 5th sine x plus 5 x to the power of 4 cos x minus 20 I3. Now, what is I3? I3 is simply the integral from integral of x to the power of 3 cos x dx. So using the same reduction formula, we go x cubed sine x plus 3x squared cos x minus, this will be 3, this will be 2, that's 6. And 3 minus 2 is 1. So what's I1? I1, the integral of x to the power of 1 cos x dx. This is 1. This is x to the power of 1. That's x sine x plus x to the power of 1 minus 1, which is 0. One minus 2 is minus 1. Of course, everything here turns to 0. 1 minus 1 is 0, right? So everything here goes off. So we have so we now say I5, which is the integral of x to the 5th cos x dx, is equal to, this is it, x to the power of 5 sine x plus 5x to the power of 4 cos x minus 20 I3. And what's I3? Everything here is I3. And that will be x to the 5th sine x plus 5x to the 4th cos x minus 20x cubed sine x, just keep following, minus 60x squared cos x. Then this times this, that will be plus 120 I1. What's I1? This is I1. That will be x to the 5th sine x so I'll use 120 to multiply everything here. This is 60, not 6. And we add a constant of integration, that's c. So this is it, I5. This is the integral of x to the 5th cos x dx. We have to determine this to 3 decimal places. This is reduction formula. We are dealing with reduction formula in this video. Normally, if I want to determine this now, okay, I'll just plug in the upper and lower limit, subtract. Plug in the upper limit first for x, minus plug in the lower limit for x, and I'll get my answer. But for the purpose of reduction formula, okay, I want to show you the reduction formula for that particular integral. Now, I5 is already this, okay, so I want to determine I5 from 0 to pi. But recall that I sub n is equal to everything we have here. This, so let me write that down. So if I want to go from 0 to pi, like in this case, it means I will be going from here. You get it? I will neglect this other thing. So plug in pi for x. That will be pi to the n sine pi plus n pi to the n minus 1 cos pi minus, we're now plugging 0 for x. 0, 0. Everything there is 0. Minus n minus 1, I sub n minus 2. This one is out. Sine 180 degrees is 0. Cos 180 degrees is minus 1. So this will be minus n pi to the n minus 1 minus n into n minus 1, I sub n minus 2. This is the reduction formula for that particular integral. The integral of x to the power 5 cos x dx from x equal to 0 to x equal to pi. Let I sub n be equal to the integral from 0 to pi will be I5. So if I5 is equal to this, okay, are you getting me? So we are trying to say that I sub n is the integral from 0 to pi of x to the n cos x dx. So if this is true, it means that I5 is equal to this because n is 5. So I5 will be using this reduction formula now. Minus 5 times pi to the power of 4. 5 minus 1 is 4. Minus 5 times 4. 5 minus 1 is 4. That will be 20. So let me just write 20. Minus 20i. 5 minus 2 is 3. What will be I3? Using the same reduction formula is going to be minus 3 pi squared, because 3 minus 1 is 2. Then minus 3 times 2, that's 6. 6i1. 3 minus 2 is 1. Lastly, what will be I1? Now just watch carefully. I1 will be minus 1 times pi to the power of 1 minus 1, which is 0, minus 1 into 1 minus 1, which is 0, times I sub n. 1 minus 1 is 1 minus 2 is minus 1. Everything here will give me 0. And we are going to say that this is equal to what? Minus 1, because this will give me 1. So we have minus 1. But do you know this answer is not correct? This is not correct. We must verify. Whenever you come across a negative subscript for I, be very careful. So I'm going to verify if this is minus 1. Let's see what it is. Just watch till the end. So to verify I1 is actually the integral of x to the power of 1 cos x dx from 0 to pi. That's what we are doing. So if you do this integration, you'll get this x sine x plus cos x. So we are going from 0 to pi. Let's see if this will give us minus 1 that I1 gave to us just now. You get what I'm saying? So I want to verify. Plug in pi for x. That will be pi sine pi plus plug in pi for x. Now that will be cos pi. I will say minus. Plug in 0. That will be 0 sine 0 plus cos 0. Cos pi is actually a minus 1. This will give me 0. Sin pi is 0. Sin 1 is 0. So I'm having minus 1 minus, this is 0. This is out. This is out. Cos 0 is 1. So this is minus 2. Can you see? Working directly from the integral, we got minus 2. But working from the reduction formula, we got minus 1. So this is actually, should I say, is the wrong computation. Well, you ask me, why is it so? What I will tell you for now is to be careful. When you get to this point, okay, make sure you verify the last solution. So I'll simply say my I1, which is the integral from 0 to pi of s cos x dx is minus 2. Good. I5, which is the integral from 0 to pi of x to the power of 5 cos x dx is equal to this. What's I5? I5 is this. Minus 5 pi to the 4th minus 20 I3. What's I3? This is I3. And that is minus 5 pi to the 4th plus 60, right? This is 60 pi squared, then plus, this will give me 120 I1. And I1 is actually negative 2, right? So this will be minus 5 pi 4 plus 60 pi squared minus, of course, minus 2 times 120 is minus 240. Minus 240. So this is actually I5. So if we attempt to leave it in decimals, not in terms of pi, this is it. So we have minus 134.869. So 3 decimal places, like we said. Okay, let's just make it 2 decimal places. 2 decimal places. We have minus 134.87 to 2 decimal places. That's all. Now you're done watching, don't forget to subscribe, like, and share this video to your friends and your classmates. In the next video, we're going to talk about reduction formula 3.